Welcome to this lecture on understanding front-end planning in construction projects. Most construction projects do not begin with a complete technical solution. They usually begin with a business problem or an organizational need. An owner may need a new facility, additional production capacity, a hospital expansion, a transportation improvement, or a replacement for aging infrastructure. At that early stage, many important questions are still unclear. The site may not be fully understood. The budget may only be a rough range. The schedule may be optimistic. The project scope, delivery method, and major risks may still need to be defined. Front-end planning, or FEP, is the structured process used to reduce this uncertainty before the owner commits major resources. The goal is not simply to move fast. The goal is to define the right project before trying to execute the project quickly. In this lecture, we will look at what FEP means, why early decisions have such a strong impact on project outcomes, how FEP differs from design and project controls, and why it is considered a construction management best practice. Front-end planning is an owner-driven decision process. The Construction Industry Institute defines FEP as the process of developing enough strategic information for owners to address risk and decide whether to commit resources to a project. This definition is important because it reminds us that FEP is not the same as completing design documents. The purpose of FEP is to help the owner decide whether the project should move forward, what solution best meets the need, and how much definition is required before major capital is approved. Different sectors may use different terms. Some organizations call it pre-project planning. Others use terms such as front-end loading, FEED, feasibility analysis, programming, or conceptual planning. The terminology may change, but the core purpose remains the same. Define the right project before execution begins. The slide also shows the three common phases of FEP. FEL1 focuses on opportunity framing and feasibility. FEL2 focuses on concept selection and preliminary definition. FEL3 focuses on project definition and execution readiness. The key idea is progressive definition. A project should not jump from a broad idea directly into full execution. Each phase should reduce uncertainty, test assumptions, and give decision makers better information than they had at the previous stage. Early decisions have a major influence on project outcomes because the project is still flexible at the beginning. During early planning, the owner can still change the concept, select a different site, adjust scope, compare delivery methods, revise the budget strategy, or even decide not to proceed. At this stage, the money already spent on the project is usually low, but the ability to influence cost, schedule, quality, safety, sustainability, and risk is very high. As the project moves into design, procurement, and construction, that ability decreases. At the same time, the cost of making changes increases sharply. A design issue that could have been resolved in a planning workshop during FEL2 may require redesign, rework, contract changes, material restocking, and field disruption if it is discovered during construction. This is why FEP should be viewed as a risk reduction investment. It improves decision quality before the project becomes expensive to change. Strong FEP helps create a more realistic baseline. It can reduce late changes, improve estimate confidence, improve schedule reliability, and increase the likelihood that the completed facility actually supports the owner's operational purpose. For construction managers, the practical lesson is clear. Planning time is not lost time. When used well, it protects project value. Front-end planning is closely related to design, pre-construction, and project controls, but it is not the same as any one of them. FEP helps define the right project. It establishes the business case, scope boundary, cost estimate, schedule logic, execution strategy, and baseline for future work. Detailed design comes after that foundation is established. Design develops the technical solution. It produces drawings, specifications, calculations, and coordination details needed to permit, procure, and construct the facility. Pre-construction usually refers to contractor services before construction begins. These services may include estimating, constructability reviews, logistics planning, subcontractor outreach, bid packaging, and procurement planning. Pre-construction is very useful, but it usually focuses on how the project will be built. FEP asks broader and earlier questions. Why is the project needed? What alternatives should be studied? What scope best supports the owner's objectives? What risks must be resolved before full funding is approved? Project controls are also different. Project controls monitor performance during execution through cost control, schedule control, change management, progress measurement, and reporting. But project controls can only measure against the baseline they are given. If the baseline is weak because the scope, estimate, or schedule was poorly defined during FEP, project controls cannot fix the underlying problem. They can only report the consequences. So, FEP creates the foundation, design develops the technical solution, pre-construction improves buildability, project controls monitor execution performance. When FEP is rushed or treated as a paperwork exercise, the problems often appear later during design, procurement, construction, commissioning, or facility operation. One common problem is poor scope definition. If the team does not clearly define what is included, what is excluded, and what assumptions support the estimate and schedule, the project enters execution with an unstable baseline. Another problem is stakeholder misalignment. Owners, designers, contractors, operations personnel, maintenance staff, regulators, and users may all define project success differently. Without early alignment, these differences can turn into scope changes, delays, and conflict. A third problem is unrealistic cost and schedule commitments. Early estimates and schedules can create false confidence when they are treated as fixed commitments before scope, site conditions, procurement needs, and risks are mature. A fourth problem is premature execution. Starting design, procurement, or construction too early may create visible progress, but it often transfers unresolved risk into the most expensive phase of the project. These problems are connected. A weak business case can lead to unclear objectives. Unclear objectives can lead to unstable scope. Unstable scope can weaken the estimate, schedule, delivery strategy, and control baseline. Strong FEP interrupts this chain by forcing important decisions to be made while the project can still respond to them. Front-end planning is a construction management best practice because it improves the quality of early decisions and reduces the chance that major risks will be discovered after the project is already committed. FEP connects the owner's business strategy to the technical and managerial systems needed for project delivery. The team must clarify the business need, evaluate alternatives, define scope, investigate existing conditions, validate the budget, develop a realistic schedule, select an appropriate delivery method, and align stakeholders. Several tools support effective FEP. The Project Definition Rating Index, or PDRI, helps make uncertainty visible by evaluating how well the project scope and definition have been developed. A risk register helps the team identify uncertainties, assign responsibility, and connect risks to mitigation actions. Stage gate reviews provide structured readiness checks before the project advances from one phase to the next. However, tools alone do not create strong FEP. A checklist can identify missing information, but it cannot replace leadership judgment. A gate review can record readiness, but it cannot protect the project if leaders approve the next phase without challenging weak assumptions. That is why this slide emphasizes the combination of tools, judgment, and discipline. When these elements work together, FEP reduces uncertainty before execution begins. Let's close with a case example. In this scenario, a major energy company considered building a $600 million processing facility to meet growing market demand. Executive leaders wanted to move quickly because competitors were entering the same market, but the company had recently experienced a major cost overrun on a similar project. This created a familiar tension. The business needed speed, but the project also needed stronger definition before major capital could be responsibly committed. Instead of rushing into execution, the owner required a structured FEP process. During FEL1, the team clarified the business objective, screened site and technology alternatives, and confirmed that the project aligned with the company's long-term strategy. During FEL2, the team compared the preferred options in more detail. Early construction input revealed that modularization of selected process components could reduce field congestion and help address labor constraints. During FEL3, the team refined the basis of design, clarified scope boundaries, mapped permitting requirements, identified long lead equipment, updated the cost and schedule baselines, and built a risk register tied to mitigation actions. As a result, the project reached the investment decision with a stronger baseline, fewer unresolved assumptions, and better alignment among business, engineering, construction, and operations stakeholders. The lesson is that FEP does not simply slow projects down. Instead, it helps teams separate real speed from the illusion of speed. Starting construction early may create visible progress, but if the project is poorly defined, that early motion can lead to delay, rework, claims, and operational problems. Disciplined front-end planning protects project value by making sure major commitments are made only after the owner understands what is being built, why it is being built, how it will be delivered, and what risks remain.